This problem here is interesting. So I'm going to go ahead and switch over to my camera so we can watch how we can solve this. This is literally three multiplication problems. One just happens to be inside parentheses, and then we're times a whole number, which we know is always a fraction over 1. So I can turn that into a fraction if I want, since that's what we're dealing with. And then we have times a negative 1/2 here as well. So there's a couple ways we can go about doing this. We can use our order of operations and do our parentheses first. I'm sorry, it keeps refocusing. Hopefully this isn't going to be too terrible to watch. But I noticed that there is a pattern here between, not a pattern, but a relationship between this and this fraction here. And they are inverses of one another. And they have a special relationship in that when you multiply inverses times each other, you get a positive 1. So I'm going to rewrite this problem using the commutative property and put it over here. And I have negative 7 over 1 times negative 1 over 7 times 4 over 5. And then this is rewritten times negative 1/2. And then using the associative property, I'm going to go ahead and move these parentheses from around these two numbers to around our first two here. So this is using the associative property, which is where the parentheses move. And then these two end up canceling out, and a negative times a negative gives me a positive 1. And then we have positive 1 times 4/5 times a negative 1/2. And we know that anything times 1 stays the same. So we end up with just 4/5 times a negative 1/2. We look on the diagonals to see if we can cancel out any common factors. I cannot this way, but here I have a 2 in common. So 2 divided by 2 is 1. 4 divided by 2 is 2. Multiply straight across. 2 times 1 is 2. 5 times 1 is 5. And a positive times a negative is a negative. So our answer is negative 2/5. Now, if I wanted to, I could just go ahead and follow my order of operations and multiply this first, rather than looking for the relationship here between the inverses. And I still would have gotten negative 2 over 5 if I followed my order of operations. So I just looked for that shortcut. But if you wanted to, and we pretend like this didn't happen here, I could just go ahead and do that negative 1 7th times 4/5. There's nothing to cancel out on the diagonal, so I end up with 1 times 4 is 4, 7 times 5 is 35, a negative times a positive is a negative, and then times negative 7 over 1 times negative 1/2. And then I can look for the factors and that I can cancel out. And right here I have a common factor of 7. So 7 goes into 7 once. 7 goes into 35 5 times. Here I have 2 and 4. 2 goes into 2 once. 2 goes into 4 twice. And then multiply straight across. 2 times 1 is 2. 5 times 1 is 5. A negative times a negative is a positive, and that positive times a negative is a negative. So no matter which way you choose to solve the problem, you still get the answer of negative 2 over 5. So don't worry if you don't catch those relationships. If you follow order of operations, you'll still be fine.